Hello and welcome to this video where I'm showing you the design and build process for my number 5 rolling ball sculpture. At the beginning I just did a little bit of 3D SketchUp just to work out exactly how the box needed to be designed. Inside the box there's a hidden bearing, and out of the bearing comes a vertical pusher that runs in a 360-degree continuous circle and pushes the balls up a curved slope track. Here you can see exactly what I'm aiming for, with the pusher pushing the balls up a curved slope track. This is a unique feature to this rolling ball sculpture, and I'm pretty sure that I did invent it. The outside and top of the box was laser cut, and all I had to do to assemble the box was to cut to length some pine timber and sand it all down, and then glue and screw and tack it all together to make a nice solid square box base. What I was aiming for was to have a groove inside the top of the box, and that was made by routing out the outside and inside circles, and in a minute the inner circle will be attached to the outer frame to make it just look like a groove. Inside the box there is the bearing. This is 17 inch or 450 millimeters diameter, and it's really important that I made it central and flat and had everything nicely screwed down together by these inside timber brackets. When that was done, the centre circle gets attached to the top, and there I have literally just a groove that goes around the top of the box. The electrics I'm using is 12 volts. It's a very simple circuit. There is a switch and a speed controller with a speed control knob, and here I'm just using a little black electrical enclosure box to house all the electrics in, make it nice and safe, and make it really easy for the end user to decide exactly what speed to use and to turn the whole machine on and off. If you go back to the YouTube playlist, you'll actually see some detailed videos as we go, and in there you might see a little bit more information about the electrics or how I solder, things like that. The motor is 12 volts and it's got a little gearbox already attached to it. I selected that to make the bearing spin at exactly the right RPM. Now, attached to the motor is a rubber wheel that's fitted with an inline connector, and the whole thing is all thread locked together to make it completely impossible for any slippage to happen. And the idea of this rubber wheel is that when you push it onto the inside race of the bearing, then the inside race of the bearing will simply rotate. All I had to do then was to make an adjustable block to mount it on, and then I had to get the pressure right in order to push the wheel onto the bearing at the right force. The speed I was going for was somewhere between 6 and 10 RPM. Now, the vertical pusher needed to be held onto the bearing, so I made a square aluminium block with a couple of threads. I think one was M4 and one was M5, and that allowed me a little bit of flexibility and adjustment, but basically it was a way of holding the vertical pusher in the correct position. The pusher was made of a copper tube, and inside the tube there is a threaded rod that is all clamped down nice and tight to the aluminium block. Then I did a little bit of marking up with a protractor to get everything looking really nice and symmetrical. I'm quite particular about how things work. And then finally it was time to add some copper tracks. The copper I use is plain copper wire, mostly it's 2mm diameter, and basically I bend and cut and solder and shape into position every single piece individually to make the framework that I need to hold the tracks in place for the balls to roll down. The first thing that I built was the rising curved track for the balls to be lifted up. I decided on a 20-degree spread for each leg, and the legs are at 60 degrees to the horizontal, which gives me a slope of 20 degrees rise. When it was finished, there was a kind of Fibonacci curve thing going on, which I really liked. Now I'm making some twisted supports. I'm doing this by either twisting together 3 pieces of copper wire or 2 pieces of copper wire to make some kind of stronger frame. That's really important to hold the top of the sculpture in place because it does get a little bit wobbly up there. When I'm fitting this frame, I used my flame solder brazing equipment in order to get enough heat into the copper for the joints to be made nicely. The next job was to fit the outer piece of track to allow the balls to go up, and it's actually really difficult this because I can't have any traditional track spaces that go between the left and the right hand piece of track because I've got to allow the pusher to go through. Then finally I could do some trials. So for the first time I could actually see if the balls go up the track. And I'm delighted to say that it worked. Then it was time to make the ball unloader. First of all I did a prototype on the bench because I didn't quite work out exactly if this was going to work or not. So I was making a track with a groove, and the balls then hit a little part of the groove and bounce to the other side of the track. It's quite complicated to explain, but basically the balls needed to jump off the track and allow room for the vertical pusher to travel on through. Basically it's a bouncing ball unloader system. Then I did a sketch and turned that sketch into a nice piece of copper. This was for the capture, for where the ball needed to land. And then all this was soldered in quite high up in the air, so that now you can see the balls are actually jumping out of the track and into the catcher. And then the vertical pusher carries on pushing and goes through on the path that it has to go. Then I decided to make a switch. This will allow the 2 balls at the top to separate and come down the sculpture using a different path. This is a kind of flip-flop switch, and it's made out of copper tubes and a little bit of grease to make a bearing that allows the switch to move from left to right. There you can see the ball goes to the left,
bit goes up,
and the ball goes to the right.
bit goes down.
I do a blog as I build, so if you subscribe to my channel you will actually see me talking through the process of designing and building this sculpture. Now I've got to get the balls down to the bottom, and there's 2 ways down. First of all I went down the inner side of the sculpture, and that started off with a little bit of a snaking zigzag thing, and the whole idea was it would be a winding, slow, nice, beautiful way down to the bottom. Here I'm testing the track again and just making sure that the balls that are heading off to the left hand side of the screen are going to go down exactly how I like them. I do love spirals, and I wanted to make a really big, ever decreasing circle, black hole type effect spiral. So I started off at the bottom and worked my way up, getting bigger and bigger and bigger as I went up. On the outside of the spiral, I had to fit all these track spacers to make sure that everything in this particular element stayed as it was. It's thinking, it's bending, it's soldering and steel wool to clean everything up. And this is a really fun part of the build, because I'm basically, with each copper joint that I make, I'm making the ball go down a really beautiful flowing pattern. And depending on the angle, depending on the speed, you know, the ball will behave in a certain way. I use lots of clamps to hold everything in place, and yeah, this is the really enjoyable part of building the sculpture. I really enjoyed this bit. It does take hours and hours and hours to make each element, and every now and again I get to do a little test. So I get to pop the ball on, clamp it all up, and there is a bell that's going to come in later. The next thing I made was the entry track to the spiral, and this is important obviously for the ball to arrive at the right speed to give it enough power in order for the ball to stay in the spiral as it goes down. And this here is the exit track for the ball to unload and then go off to hit the bell. Once the element's made, it's a case of setting it up, making sure it's in the right place, getting everything level, and finally deciding to connect things up and set it all in place. These connectors here are just doing the top piece of track that are going to go from the switch into the top of the spiral. So finally I can try the ball for the first time all the way from the top to the bottom. Now I decided to fit a bell to this sculpture so that when the two balls arrive at the bottom, it goes ding ding, and hopefully they would land at the bottom within a second and the balls would hit the bell and make a nice sound. Once I got the bell in place, I could test. Oh, and it's absolutely wonderful. It's such a nice sound. So that one ball works really, really well. Now it was time to make the second route down. I drew this one a little bit and used my copper bending jig to make a little catcher, because one of the first things I had to do was to get the ball to jump across the gap and leave room for the vertical pusher to come through. And here you can see me just deciding exactly where to put the catching arm. I've got to get the height right. There you go, a little bit more up, a little bit of slow motion trials, and I'm happy with that. Then I made a series of small loops, and I even made a little figure of 8 at one point in order for the balls just to loop their way down along the outside. I really wanted to make some kind of ballet dancing thing or figure skating where the two balls come down simultaneously and do a little dance as they come down. Then it was time to join everything together, and for the first time have the ability to get both balls from the top to the bottom, and so it was time to declare the sculpture was finished and to make the finished video. To begin with, I'm just showing a single ball rising to the top of the sculpture, and this ball will come down the inside track. Now for the second ball. So the second ball goes down the outside track, and like I said, there's lots of little flowing circles. That's the jump. Lots of flowing circles. There's a figure of 8, and then the ball goes into my favourite part of the whole sculpture, which is the serpentine. This is about the 3rd or 4th serpentine I've made, and I'm very proud to say that it worked first time as soon as I built it. It's also the first one I've made that's on a slight curve. It looks amazing. Now it's time to fully load the sculpture with 2 balls in front and 2 balls behind. So to begin with, on the first circuit, the 2 balls are lifted up to the top of the sculpture, and the 2 balls are waiting at the bottom to be collected. When the pusher comes round, it collects the bottom 2 balls and sends them on their way, right at the same time that the 2 at the top are starting to come down. This gives the people who are watching the sculpture enough activity to look at. You can watch the 2 coming down, and once they've finished, the 2 on the way up are about halfway up or a third of the way up, so there's always balls on the go. If you have liked this video and the build series, then please do consider subscribing to my channel. It's really important that I grow the channel. I absolutely adore seeing the numbers get bigger, and I love the likes and the shares and the comments that you make. There are links in the description to the soldering kit that I use, because quite a lot of people want to know what I'm doing. It is a little bit unusual. It's resistant solder iron. And there's also a link to my Etsy shop and my website, and my email address is there, and I do totally welcome your feedback and your ideas for improvement, or even just for you to say hello. I enjoy what you're doing. That's really good. If you're in the UK and you want to actually see this sculpture, then you can go to the Mad Museum in Stratford upon Avon. It's on permanent display there, so hopefully if you're in the area you can go and check that out. Like I said, please subscribe to my channel. I'll see you later on in the year for the next copper gravity rolling ball sculpture build. Thanks for watching, all the best, goodbye!